Alright guys, let's get started here. So as we're approaching our couple of days of the semester, I've been working on this board called the toggle board, made by me, Given Franco. Alright, let's go to the next stage. Alright, so what is the toggle board? The toggle board allows you to create, analyze a RCL circuit all in one board. So this means no building is required. You don't have to fiddle around with the breadboard and try to make it yourself. It just saves you time. The cons are you can't measure the current going through the components because of course they're going to be soldered onto the PCB. But you know, the pro side is you save time. Let's go to the next page. So here's the circuit. As you can see, we have a couple resistors, some switches, 4 capacitors, and a inductor right here. So you could toggle basically between the switches to, let's say you want to measure a voltage divider. The switch this one down, then go over here, switch this one down, you measure here and here with your multimeter, right? Let's say you want to do you say you want to use this inductor here in your circuit. You're gonna switch it on here. Make sure this is switched on over here, just in case something happens here with this wire right here. And basically, you just toggle between the switches in order to configure the circuit. Let's go on to the next page. And here is the PCB. As you can see, it looks pretty nice. You got the input here, resistor, switches, and then I had to use some jumpers because the PCB needed jumpers, just to make the circuit work on the PCB. Alright, here's the setup they're going to be using. You have your function generator. I have mine at home. Got my oscilloscope. I got the board right here. As you can see, it's already made. PCB with all the components on there. You got the probe from the oscilloscope. You got the probe from the function generator. You see all over here. The probe, and you have the probe from the function generator. So I'm measuring, it's hard to see, but I believe that's R2, and this, I think the inductor side. As you see, here's the waveform on the oscilloscope. Let's go to the next page. Yeah, here's circuit number 1, test circuit number 1. So I simulated this circuit in LT Splice, and then these are the values that I got, right? And on the board you're going to be switching on the proper switches to configure the board to this circuit here, and we should get a max of 14.2 volts at V out 1 right here between these two resistors, and a max of 322 millivolts at V out 7, which is right here, inductor. Alright, to the next. And here is I'm measuring this from the board. As you can see, the oscilloscope. Our max on the board for what is this? V out 1 is, the top is 3.95 volts. Close. It's pretty close. You see. And then we have for V out 7, the top is 346 millivolts. Again, pretty close. course, it's not going to be exact because the simulator and real life is different. You know, you gotta take into effect some losses in the circuit. Right, so let's go to the next one. We have a second circuit, circuit number 2. And again, we're gonna configure the board with this circuit here. Right, our max at Vout 3 should be 52 millivolts, and then our max at Vout 6 should be around 38 millivolts. Right, here's the circuit, here's the waveform. So we're gonna measure Vout 3, which is gonna be right here, and then Vout 6 should be right here by the capacitor and resistor. Let's go to the next. I'm gonna look at the oscilloscope, and it's a little noisy here, I guess, because of the oscilloscope. But let's look at our Vout. So Vout 3 is about 50 millivolts. Again, but pretty close. And then Vout 6, we got 38, and then here we have 35.3 millivolts. Again, pretty close. All right, let's go to our final circuit here. Circuit 3. As you can see, I'm going to configure it to this circuit here. You see, this here is very important here, and it's all grounded. This whole area from the capacitors, this whole side is going to be grounded. So we're going to configure that on the board, right? And then we have our input right here, goes here. So it's basically a voltage divider now. It's here with this inductor. So we're going to measure Vout 1, should be 14.2 volts, and then Vout 2 should be 263 volts, right? Peak. Go to the next one. There we go. On the oscilloscope, as you can see, you got about 4 volts, close to 4.2. And then we have the Vout and V2, 2.63. Again, pretty close. Go to the next circuit. Alright. So, of course, like I said before, the board allows you to quickly test the circuit and no time wasted. You can configure a bunch of different types of circuits, RC, RCL, or just voltage divider. Here is the board with the PCB. Got the switches. You got your capacitors right here. You got inductor right here. This big thing right here looks like a transformer, but it's an inductor. Black is the negative. So it's just a visual representation of what the negative is going to be, where it's going to be on the board. Got our input right here, right? Got resistors, and these P's over here are going to be your test points. So test points at P's, right? And like I said, you know, remember those jumpers right here? There you go, those jumpers are right there. Let's go to the next circuit. I mean the next page. So how did I make this board? I made it myself at home. Right? I used a laser printer, and then you gotta use special paper though, glossy paper. You're gonna use what do you call this thing? Iron. Well, you know, this thing here. Right, you're gonna transfer the toner onto the copper PCB. It's all copper, right? You're gonna sand it a little bit, so it makes good contact, right? You're gonna, with a lot of pressure, put the paper here, and then it's gonna transfer the toner. Then from that, you go over to your etching solution to etch it out, right? Everything that's covered is not gonna be etched, but everything that's uncovered will be etched. Let's go to the next one. So here's my fail number 1. Yes, I had failures. First PCB had many issues. I was trying to make a double-sided PCB. I didn't take into account, that I was going to be using through-hole components to make the PCB. So yeah, a bunch of issues due to the lack of planning. I just was going off by gut, by my head. I wasn't really planning. So this is my fail number 1. It turned out okay. I didn't like it. I didn't like how it was turning out. See, it's all everywhere ugly, right? Version 1. And then I had to use a bunch of jumpers everywhere because of the double-sided, and then they were making contact with the switches. And yet this didn't turn out how I liked it because it was the wrong orientation, and I wanted to remake it, so I remade it, and here's the final product right here. Right, a bit better, looks way better. Only one-sided, right? You got all your connections right here, your wiring, right? Looks all nice and clean. And then version 2. This bottom part, it's covered by tape, so it didn't etch away. That's okay. It's not gonna ruin the circuit or it from working, so it don't matter. So here's how it looks. Looks nice. I drew with the Sharpie on the top, the red, just to show you visual representation, like I said before. Black is going to be where the ground is, right? So you know where to switch the toggle the switches to ground. Right. All right. And conclusion, that was all in one toggle board. Saves you time, and then you have more fun, right? So here is the links to the gifts that I use, just in case you like them. They're not my property, so I put this here just in case. So that's it for today. Thank you for watching.